Hi everyone, it's Zorkan. Today we have a problem when we are given a string path, which is an absolute path to a file or directory in a Unix style file system, and we need to convert that to the simplified canonical path. We are also given an example of the requirement for the canonical path, which is our canonical path should start with the single slash. Two directories should be separated also by a single slash, and also the path should not end with the trailing slash, so which means that the path should not have an ending slash. And we are given an example here. For example, let's say that we have home, we have a slash home and the ending slash. So here we are converting this is a Unix style file system path, so we are converting the canonical path, which is we are removing the single slash from the end of our path. Let's take this example and work on it. So let's say we have this Unix style path and we need to convert that to canonical. So what we're going to do in this case, we are going to use a stack data structure. So what we are going to do, we are going to first take our string and split it by the slash. So how many elements we are going to have here? So we're going to have home, right? We are going to have user1, and we are going to have two dots, and we are going to have user2, correct? So we are starting to add one by one. So first we are adding home here to our stack, right? So we are adding home. The next one is we are adding, so we have added home. So the next one we are adding a user, right? User1. So we are adding user1. And the next one is that we need to add two dots, but the two dots is referred to the directory up, right? In directory up in our case. So directory up, it means that it refers to home. It means that we need to remove the user from here, right? User1 from here. So that's what we are exactly doing here. So we are taking that user from our user1 from our stack, right? And so we are taking the user1 from our stack. So user1, and we have for the two dots, right? We took the user1, and the last one is what we do. We are adding user2, right? So now in our stack we have only two elements, home and the user2. So what we're going to do now, after adding that to our stack, we need to reconstruct our canonical path, right? So we are going to go over our stack and add them one by one. So we are creating a new string. So we are starting with the slash. So we are adding home, and we are adding slash, and we are taking the next element, which is user2. So we are adding a user2, and this is the result that we are returning. The first thing that we do here is we are creating a stack, and the next one is that we are splitting our path by the slash, and we are getting the array of strings, right? And we are calling them components. The next one is that we are going over our components, and we are checking that if our current component is equals to two dots, right? What it means? It means that it's a directory up. And if we are checking that if our stack is not empty, because if it's empty, there is no directory up, right? So if it's not empty, then we are popping up that element, the latest element that we added. The next one, if it's not equal to two dots, then we are checking if it's not empty, and if it's not dot. If it's dot, it means that it's a current directory, so we are just skipping that. If it's none of this, then in that case we are adding that to our stack. At the end, when we complete this part, so we have in our stack our complete directory, our complete canonical path, right? So we are creating a string builder, and in our string builder we are going over each our element in our stack, right? Starting from the first element, and we are adding that to our result and adding a slash. And the next one, the last one, is that we are checking that if our length is more than 1, right, for the result, it means that we have a path. So in that case, we are removing here our slash, right? So by requirement, our canonical path shouldn't have an ending slash, so we are removing that from there, and at the end we are returning our result. So what's the time and space complexity of our solution? The time complexity is that is determined by these two for loops, right, in both of these cases, and in both of these cases, so we are going over our components or over our our components once, so it's a 2 of n, so we can consider that of n. And the time complexity is determined by the stack and the components, and it's 2 of n. We are considering that as an n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.